Hello and welcome back to my RC channel. I'm Andy RC and today I'm going to be taking a look at the YRRC 8030 GPS module. Now it's becoming a popular thing to add these lightweight GPS modules to mini quads because Betaflight now supports some GPS functions. There's no compass on this guy, but Betaflight has a mode called Rescue Mode where you can flick a switch and the model will return back to you. I think the idea is if somebody powers on or you lose video or something like that, then it will start to fly back to you. It will increase its height and then fly back. However, when it gets to 200 meters away from you, then that function will disable itself. And the idea is that you should be able to get your video back at 200 meters and they don't want it flying into you. However, I don't think you'd see the model from 200 meters away unless it was a big model, so I'm not too sure on that feature. I don't think it's really safe. But what is good about these things is that they are light. This one weighs 5.9 grams and you could put it on a 3-inch model and I don't think it would affect its top speed too much. I mean, maybe a little bit. You could put it on a smaller model, maybe a 2-inch model, but then it would definitely start to affect its speed. So I'm interested in using this to see the speed of a model rather than using a radar unit. However, in the past, the reason why I haven't used GPS units to measure the speed of copters is I used the FrSky one and it was just giving wild figures. I think it was like a 5-inch Freestyle model and it was saying it was doing 116 miles per hour or something like that, which it would never do. So I'm not sure about the accuracy of these things. There's a lot of arguing online whether radar and laser versus GPS is more accurate. But for me, as long as you have got a baseline, then I'm not really too bothered about the figure. It's more about comparing models to other models. And even if the number is wrong, then if you use the same unit for the speed, then you know that one is faster than the other, even if it might not be a completely accurate number. So these are being used a lot, but not this one. I haven't seen a review of this one, and there's no manual for it either. However, they've made it really easy because we have got all of the cables labeled up, so that's ground and 5 volt, although it will run off 3 volt I believe, and then we've got the TX and the RX, so it's very easy to wire up. The TX will go to the RX of a spare UART and the RX will go to the TX of the same spare UART, and then you will set it up in Betaflight. And then this is your antenna, so that needs to face upwards. And a lot of people are using these GPS units. This is the BN220, but I think they do a BN180, which is a little bit smaller and more the same size of this guy. And they both have their benefits. For example, this wire here, it is silicon wire, so it's going to be easy to solder up. This guy is using a plastic wire, so not only is it going to have a bad solder joint, then it's going to melt the plastic of the wires. But what I do like about this guy is that if you want to do away with GPS for whatever reason, then it's on a 4-pin 1mm pitch JST connector, so you can just disconnect it. And if you want to change the wires to silicon, then you can buy these connectors. So yeah, like I say, there are positives and negatives. You also don't get a heat shrink with this one. You do get this foam pad, though I guess that is to cushion vibrations. You also get a spare wiring loom with this guy, and it comes with servo connectors on the other end, but of course I will be soldering things up with this guy. Another benefit is that you can actually set up to have the longitude and latitude on your on-screen display. So if you crash and you're recording your DVR and you can't find your model or it's thrown a battery, then you have got the coordinates. So you can just go on the internet and find its last known coordinate and then hopefully find your model. So I've hooked everything up, and considering my main interest in this GPS module is how it records speed, I have attached it to the Diatone GTR 369, which on the previous video to this one with a radar speed system got 124 mph as its top speed. Now you might be thinking, Andy, why have you mounted it at a strange angle like that? Well, this is essentially a patch antenna. So it has got a limited field of view. It's got high gain but a limited field of view. And I've seen people just putting them flat on the top there or maybe on the arms, but the problem is we fly forward like that. So if you put the antenna flat, then it isn't going to be facing the sky, it's going to be more facing, well, I guess the ground. So if we put it at an angle like this, we have a better chance at it reaching the sky because that is where it's receiving its information from. Now ideally I wanted to have this antenna positioned at the back because the Copter is going to be blocking potential satellites that are at the back. However, if I moved this up, then it would block my video signal, and I'm going to need a really good video signal for doing these speed tests. Now, you could say, well, why don't you just extend the antenna? Well, we have the same problem, really. I guess it's not quite as bad, but extending the video antenna will still block the field of view of the GPS antenna. If you look at any of the car GPS systems, they always say to mount the antenna on a flat surface, and this is why I'm skeptical regarding what speed reading this thing is going to give, because I can't guarantee that it's flat, and I can't always guarantee that it's not going to drop satellites and give incorrect information. Now, I know this has been done to death, but I wanted to show you guys my Betaflight setup because this is a new thing for me. Now, I've done a lot of reading up on this, so I'm pretty sure that I've got everything right. But if you guys spot anything that may affect the results of this video, then I'd like to know in the comments. But I'm going to connect to the Copter and first of all go to the ports tab. So I've connected the TX and the RX up to the UART6. So we've got GPS selected as the sensor input, and I've got the baud rate set to 115,200. Do not set it to auto because it's just going to pick a random setting, and this figure here is going to affect how quickly that the flight controller is going to process the data received from the satellites. So I know that this chip in this module is the M8K series chip that is also in the BN220. So it can support this baud rate, but if you choose a lower baud rate, then in your on-screen display you will get a bigger delay of the information being processed. So it may be different if you've got a different module, but I've done my research and this board can take this baud rate. Sorry for the pun there. Then if we go into the configuration tab, I have got GPS selected and also GPS ticked there. The protocol I've got as U-blocks, and I've got auto baud turned off and auto config turned on, and then ground assistance type I've got as auto detect, So that's everything in there. And then really the last thing to do is your on-screen display and what you want to get out of it. So I have got the number of satellites because that's really important. I've also got the home direction. I haven't put things on like the longitude and latitude because it starts to get cluttered, but I could see how it could be very helpful. However, I'm just really interested in what it's going to read in speed. So we have got the speed here, and I've changed it to imperial, so this is going to be mile per hour. I've also put the altitude on there as well, but really I don't think we're going to get good information out of this. It's usually if your flight controller has a barometer where this is more accurate, and even though this is the F7 board, unfortunately it doesn't have a barometer. And then down here, finally, we can, on the end screen, have max speed selected. So those are all of my settings that I have got. The first thing I need to do is put the Unify into pit mode. So I'm going into the config tab, going down to pit mode and changing that to PIR. Then go back and up to set and select yes. Then I need to save the settings, and when I power cycle the battery, then it will be into pit mode. So I'm going to unplug the Lipo now and plug it back in, and once it settles down, then we are in pit mode. You know that you're in pit mode because when you move the goggles away, we get static like that. So we need to do what is called a cold start on this GPS module because it doesn't know where any of the satellites are because it's not been used before. So I've got a spare 4S LiPo, that's why it's saying 16.7 volts, and it's going to take a long time for it to find all of the satellites. And let's switch to when it's done that. So it's taken 9 minutes to find 10 satellites. So then I switch the battery to the 6S, but I now need to go out of pit mode, so I'm going to change that. But you will notice that the number of satellites are the same. It's 10, and that is called a hot start. It remembers the satellites. So this is actually the first time flying, and you can see we've got 10 satellites there, and you can see the mile per hour in the bottom right corner, and I'm using the same space that I usually do, and it goes 49 mile per hour, and I'm like, what? Is that mile per hour or meters per second? But it turns out that you need a lot more space because there is quite a delay between the information being received from the satellites and it getting processed by the flight controller. So on that second run it nearly reached 100 mile per hour, but I'm having to go really far out here, and then let's do full throttle. This is with the 550 milliamp GMB LiPo, and we have hit 121 mile per hour, so very similar to what it got on the radar system. However, it's not as consistent as the radar system. So just check out this run here. So full throttle and a bit of jallow, but look at that. We only have got around about 76 mile per hour. I went higher there because I'm actually losing satellites. Can you see? It's gone down to 5 there. That is the trees blocking the satellites, I think. So yeah, I think I'm still going to be using a radar system, and who knows, maybe it is this GPS module that is making it inconsistent, but the radar system is much more consistent. Now, let's check this out. 144 mile per hour. We've either broken a record there or that is just duff information. But let's just see what else that it does a few frames later. 169 mile per hour. I've either broken a record there or that is producing duff information. But let's skip 2 frames on. 222 mile per hour. If I do that in the opposite direction, then because it's GPS, clearly I'm a record breaker. Sorry, that was just a joke, because there's a lot of people on the internet saying that, oh yeah, it's only a record if it's recorded by GPS. But yeah. In all seriousness, though, I think GPS is a fantastic thing, and I want to thank the Betaflight devs for implementing it. And one of the main restrictions of getting new people into the hobby is not having redundancy and, you know, ways to rescue your model. By the way, did you see that little bit of jello there? I didn't report on that in my review of this model because it was a dreary day, but yeah, in high exposure situations you do get a little bit of jello with it being a CMOS camera there. But yeah, I think it'd be great if we could have a compass, and then you could have like a DJI experience almost, but then have a switch that you could flick that sent you into full acro, and if you have a issue then you have a panic button which will send it into a loiter and then return to home. But look at the speeds again, you know, not reaching 100 mile per hour. Alright, yeah, the voltage is sagging there, but yeah, I can't use this as a reliable source, I think, for the speed. But what I did think was funny is the end stat screen there. So let's just land and see what that says. Max speed 222 mile per hour, a new record. Not really. Now, I know people who heard me say it earlier about having a DJI-like experience where you can have a loiter mode and a return to home mode, and then at the flick of a switch go into acro, mention things like Mission Planner and ArduPilot and especially iNav. But those separate entities aren't focused on mini-quads, therefore their acro performance isn't as good as Betaflight. They can do acro, but of course Betaflight is all about getting the smoothest flight out of your acro model. So it's really good to see Betaflight implementing GPS features, and I hope that continues to the point where we can have things like return to home and loiter mode. I also think as things get smaller, as inevitably they are doing, then we could perhaps mount these GPS modules with built-in compasses on little mounts, just like we do with our VTX antennas, and maybe that will make them a little bit more accurate. But until then, that is my review of the YRRC GPS module. I'll link it in the description of this video if you wish to buy one. And as always, thanks so much for watching. Please continue to subscribe. Cheers.